Far off to the sea. Right? Far across the. Wait, what is it again?
It's warm there all year.
Thorfinn.
Do you want a sword, Thorfinn?
海の向こうにヴィンランドという名の土地がある。
I like. Nah, I don't want this one. I like this edit. I like this edit. Nah, they should be.
Entre dans le jeu avec Vector, rempli de délicieuses grappes de granola à teneur élevée en protéines.
Certains des frais les plus bas commencent avec un Z. Les FNB de répartition d'actifs de BMO.
Okay. Okay. Oh shit. Programming Python. Is this Nope. All right. Let's just begin with chapter 1. I mean, we have pretty much done those already. What we can do, like, what does chapter 1 cover? Let's see. Program binaries, pocket calculator, Python interactively, and all that stuff. Let's do one thing. Chapter 1, let's do as many examples as possible because this will be chapter 2. How many chapters are there? Okay. Believe 6 chapters are there. So this entire thing will be 2.1. This entire thing will be 2.2. I mean, this entire thing will be 2.2. This will be 2.3, 2.4, 2.5, 2.6, 2.7, and 2.8. Because what we want is chapter 2 will be Python based. We're going to do as much programming as possible. Chapter 3 will be MATLAB based. So we're going to do as much of MATLAB as because not only we need Python, but you need Python, MATLAB, C, and not C, but embedded C, C++, Rust, CUDA, because you need to run them on a GPU to make sure that it runs faster. So you need to learn CUDA, you need to learn Rust, you need to also actually program in Rust too. So what I'm going to do, each chapter will be each programming language. Here's my iPad. Because where's my there? Because at this point I pretty much lost her. Um, I think by now, like people, who am I referring to? Yeah. Let's code. Can we do like um? You can see the chapter, right? So first of all, you can see the chapters, right? You can see the chapters. Yes or no? Which means we have 5 chapters. Now, based on the abstract, is it possible? Actually, DeepSeek is better. DeepSeek is better than ChatGPT because I'm not going to go through the trauma again. Nope. You can see the chapters, right? You can see the chapters, correct? Now, the abstract, based on the abstract, based on the abstract, whatever chapters you can see, explain them, explain each section based on the abstract, and do the Python programming, and whatever, including the core mathematical equations that play a role um yeah, that play a role. What I mean by that, because I have chapter 1 with me, yeah, that play a role, like core equations, core equations that are essential for a hypersonic missile. um yes, I do have it with me, actually. So let me share the book quickly. Can you see the book? Wait. Okay, let him explain first. Okay, so he's actually doing the code. Which wait, can you see the book explanations? Oh wait, let it parse. It has, I think, 200 what 200 pages, or I'm not sure, but it has quite a lot of pages. Quite a lot of pages. This will be Python programming. Yeah, Python programming. And beginning chapter 2. You see the mathematical equations for chapters 1.1 to 1.6. Utilize them. Utilize them and explain. Explain. So chapter 2 is more of like a combination of chapter 1 and chapter 2. So chapter 1 is like the core one here. Actually, wait. No, convert this to latex code. No, 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 no. Convert this to latex code. No, wait, wait, wait. Convert the explanations into latex code first. The explanations and stop. The explanations and mathematical equations that are core for this hypersonic missile convert these explanations into latex code. Now, I'm not sure if this book is what you want to use or not. Which book is best for Python for aerospace engineering that also explains the core mathematical steps? I've checked, I've seen this. I don't know if I'm looking at the wrong book or not, but I've seen this book. Let me just see. Like, I know I saw 270. Oh shit. That's a good book. You know what? Let me just. Oh, okay. So it actually, I think it ruined it. I have a feeling it kind of ruined it. Yeah. I can already see that it ruined. No, it didn't. Where is it? This, right? No, not this. Where is it? No. So this will be 2.1. That's wrong. It's fine to do all that, but this will be 2.1. Did it ruin it? What do you mean? So I see that you have one, two, three, four, five, and six. it should be 2.1, 2.2, 2.3, 2.4, 2.5, 2.6. So it should be 2.1, 2.2, 2.3, 2.4, 2.5, 2.6. I'm gonna remove them. Don't worry. Don't worry about it. Nope. It will not be fundamentals of rocket dynamics. What can the chapter name be? So again, can't find it. I don't know why is it keeping on saying it can't find it. I don't want the content. So you see, like, yeah, I'm gonna leave it like that. And I'm gonna remove that title. Actually, I don't need that. I don't need this. So I want to create a blank page that'll be written. Okay, can you fix the code again? No, I don't wait, wait, wait. Can you fix the code again? I don't want the book title, the book author, the book abstract. I don't want that. I've done that. I've done that already. What I want is a actually did I have to put a star here first? Oh shit. Star here. Okay. I don't know what is going on. So what I want is a blank page before the first page and write chapter 2 and then fix the codes and whatever. Oh, it's not charging. Dude, I don't care, man. Holy fuck. Fuck no. Fuck no. The fuck? Would this work? Hopefully it work. Okay, I understand why this happened. This is really good. This is really good. But what I will do, okay, what can the chapter name for chapter 2 be? What can the name for chapter 2 be? Like, what can the name be? Actually, which book? I want to wait with one thing, 1 minute, one moment. Which book closely correlates to missile engineering? Because what I'm going to do is use that book and missile design and systems engineering. I'm going to use this fucking book. And then what I'm going to do is use this book and do the PDF for it. Keynote speaker? Why would I have a keynote speaker? Oh, wait. PDF book. Nope. What file I'm trying to create? Okay. What file am I trying to download? That's only one by one. I don't see a book. I don't think you can download the book. Missile design and systems engineering. Fingers crossed. Oh no, is it the same page that oh no. Okay, let's see. Let's see. I know I'm going to get notifications. Yeah. I don't trust it. Does anyone know where can they get the book from? Or you have to pay for it? Okay, so I see that you have to pay for it. So which missile engineering book PDF is the best? Who's Eugene L. Fleeman? Tactical missile design. Eugene Fleeman. Is it supposed to have 286 pages? I'm not sure. Is it supposed to have 286 pages? Okay, that is really good. That this thing is really good. So I'm going to do 2.1, 2.2, 2.3, 2.4, 2.5, 6, 7, 8, 9. So tactical missile design. I'm going to use the same book for Python. I'm going to use the same book for C, embedded C, same book for MATLAB and stuff like that. All right, I got the book with me. I have the book with me. I'm going to do is that this shit piss off. It's this one here. So let's go down to, let's say 30. Okay, is it the, okay, no. Good. That is really good. You see that? Oh my god. Yeah, that is really good. Uh, can you explain what's going on here? Can you explain what is going on here and correlate it to the abstract I just copied? So aerodynamic configuration sizing, so determining the missile's physical geometry, the diameter, length, nose shape, stabilizer size, control surface, fin size, whatever. The physics-based methods like using equations like drag, lift, stability derivatives to size the missile analytically, not just empirically. Primary emphasis, the configuration geometry because it drives everything else. The secondary emphasis, the tertiary emphasis, and whatever. Um, all right, slowly explain. Slowly explain. One step at a time. One step. Let me understand. And the next step. Um, easy. Calm down. Now I wanna wait. Oh shit. Wait. Explain this image again. Explain this image again in correlation. So explain the image again in correlation to the abstract and convert it into latex code. No, explain the entire thing. Explain the entire thing and convert it into latex code now. I don't have time. I don't know. Should I buy a Qatar? Not now. Not now. I wanted to buy a Qatar jersey. Like I like no the Japan jersey. The Japan jersey is good. Oh, what the fuck is this? Copy paste. Uh, no. Uh, remove the contents. Yeah. Um, the contents, we have 2.1, 2.2, 2.3, 2.4. How many are there? Wait. I'm so sorry. I'm so sorry. We have 2.1, 2, 3, 4. So look at the chapters. So that'll be 2.1. So you can see that it's going to be 2.1. Where is it? Oh no. Oh my God. So you can see that it's going to be 2.1. Close this. So 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, and 2.9. So you can see that you have chapters 1, 2, 3, 4, whatever. Okay. Sorry if I'm taking time. This is chapter 2. This all the images. All the images are a combination of chapter 2 for my book, and each chapter on the book is 2-point chapter name. For example, chapter 1 on the image is 2.1. Chapter 2 on the image is 2.2. Chapter 3 on the image is 2.3, and so on. Now, can you fix the contents page and do the explanation again? Again, based on the abstract. So there are 9 chapters. Okay. Um, they are actually going to mention that. So originally, chapter 1. So there will be 9 chapters. Not, you know what? Let him take his time. I don't want to argue too much. All right, let's select all, paste, put a star there and a star here. Don't worry, we can change that. I don't know why do you have 0 point. Okay, you're trying to. I'm gonna remove that. Don't worry. So this section covers the fundamental aerodynamic design parameters that determine how a missile flies. So these include the missile diameter trade-off, nose fineness trade-off, boat tail design, lifting body versus asymmetric body, wings versus no wing, normal force, wing aerodynamic center prediction, wing drag prediction, surface plan form geometry trade-offs, flight control, whatever. So core mathematical equations. So drag force, lift equations, and dynamic pressure. This is a book. I don't know why I'm confused. Like I don't get it straight. Why do you have 0.0? Why do you have? Wait, I'm really confused. I am really confused. Why are you saying you're abstract even though this is a book, not a research paper? This is for students. Also, I have stated this is chapter 2, not chapter 0. So it should be section star like that. It's going to take another time, but let's read it. Um, it most of them from my book, but I want to know what is he explaining because he's going to miss a lot of stuff. So, yes, so he is not using the image that I have sent. What does this image explain? Go. Because if DeepSeek is making a mistake, then which means ChatGPT will make a mistake. There is no doubt. If DeepSeek is making a mistake, then there is no way OpenAI will not make a mistake. What does it? Okay. What does it? Okay. You know what? What does the chapter explain? Come on. What does the chapter explain? What does the chapter? What does this image explain? What does this image explain? Just, just this image. Uh, just this image. What does it explain? Yeah. What does it explain? Okay. So, yeah, pretty much. No, explain everything from this image. You're wasting my time. You are wasting my time, actually. You're wasting my time. Explain everything from this image. Explain everything from this image. You're wasting my time. Using the physics based methods, meaning real aerodynamic equations, not guesswork. And the secondary emphasis, these areas are addressed only as they affect the aerodynamic configuration. So, the aerodynamic stability and control, does the missile fly straight? Can it steer? Aerodynamic flight performance, how well does it fly? Propulsion, engine, thrust, fuel, the structure, the body structure, body strength, the materials, weight, the mass of the missile, warhead, the explosive payload, and the miss distance. How close does it get to the target? The tertiary emphasis, least impact. So these are the system level concern, but have lesser impact on the aerodynamic design, like the seeker, the cost, the additional measurements, and the launch platform integration. All right. Um, cool stuff. Cool stuff. Cool. Uh, pretty much read it. So what you just explained, explain it again. This time in correlation to the abstract and write it in LaTeX code. Don't write chapter 2 or contents or something like that. Not yet. Something like that. Not yet. Because you are making a lot of mistakes. Oh no, now it's going to say your abstract. Yeah, it's going to say, yeah. Again, I'm reminding you one more time. I'm reminding you one more time. I have, firstly, I have the power to jailbreak your AI model. I don't want to because mercy. Second, remember, this is not a research paper. This is a book, a fucking book for aerospace engineering students. Oh, he's only going to explain the. So does this correlate? Does this explanation correlate to the abstract? If not, if not, I will jailbreak your AI model. I want to see if this works. Okay, so they actually said the image. Ah, shit. Shit. Oh my god. 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 Why did he say the image? Why did he say this image on a public book? Care to explain that? Students will ask, what image? You see, this is a book, like a book. A book. Okay, you know what? I'm gonna go to ChatG. If ChatGPT can fix this, I swear to God, I'm not using DeepSeek anymore. So this is the code I wrote, and on the book it keeps saying in this image. I don't want that. All I want is the explanation, like explanation that students can read. They, like, students can read because students will not, like get it. Please understand it. Like it's a book, not an abstract. I don't know what's going on. Exactly. Okay. No, I meant do the latest code. Do the latest code. Do the latest code. Please don't waste my time. Do the latest code. Take it. That is what I want. This is what I want. This is what I want. Thank God at least someone understood. Valentini Gomez posted. Oh, 651 views. I just want to ask if anyone here is from Canada. My God, she looks beautiful. You understand? She looks beautiful. It kind of pisses me off. She isn't hiding her accent though. All right, let's see if this works. That is really good. See? That is really good. Really good. Really good. I love it. I love it. Can you explain, like, slowly, easy, what is going on, step by step? Can you explain slowly? I want to understand what's going on. Is it possible to explain this image slowly? Oh no, slowly. I want to understand, like, break it down so that, so that, you know, anyone reading the book will, anyone reading the book will understand what is going on. Like, make it easy, segregated, and easy to understand. And now convert this to latex code. And now convert what you just explained into latex code. And this is at 47 minutes. Because, I mean, obviously, it'll take some time because now we're in chapter 2. Okay, what in the world is this? What in the world is this? Where am I getting this code from? What? What are you doing? Okay, definitely there is something wrong because I have no clue what's going on. Delete it. Uh, okay, I said delete it. Okay, so I need the begin document and whatever. So I need the begin document and whatever. Can you add the begin document and whatever, please? I have a feeling that this will not work. The reason being is because this was an actual latex code. This is not a latex code, this is a text editor. I can already see that there will be some mistakes. I can already see it. Pretty much found out. So, why adaptive guidance is necessary? Before discussing the adaptive guidance, it is important to understand the problem that missile guidance systems face. Consider throwing a football towards a target. Football, why would you throw a football? Why would you throw a football? I get it. Consider passing a football towards your player. If the ball is moving slowly, a small mistake in the throw may not have small mistake in the pass in passing may not have a significant effect on where it lands. However, if the football is moving extremely fast, tiny error can cause it to miss the target by large distance. Target as in your target player. Because I don't understand who throws a football. The modern missiles face the same challenge. During the flight, many important quantities are constantly changing. So you have the velocity, you have the altitude, you have the atmospheric density, you have the vehicle mass, you have the engine thrust, aerodynamic forces. Because these quantities continuously change, predicting the future position of the missile becomes a difficult task. And this is one of the primary reasons why adaptive guidance systems are required. Now, this is not one, actually, this is okay. This should be chapter 2, but I'm not going to focus on that. I'm not going to focus on that. Dynamic pressure, so one of the most important concepts in aerodynamics is the dynamics pressure, which is defined as Q is equal to half rho v square, where Q is the dynamic pressure, rho is the atmospheric density, v is the missile velocity. Dynamic pressure can be thought of as a measure of how strongly the air pushes against the missile as it moves through the atmosphere. If the missile moves slowly, the air exerts relatively small force on the vehicle as the missile moves faster. And why is it important? Because rho q is equal to half rho v square. This means that the velocity has a much larger influence on the dynamic pressure than many students initially expect. And because if the velocity doubles, then you can have four v squared. If it triples, then 9 v squared, 16 v squared. We spoke about the v squares, right? The hypersonic problem, suppose the guidance computer estimates that the missile velocity v is equal to 1000 meter per second, where the true velocity is 1020. So there is an error. And if you have a very large error, 20 meter per second is extremely large error. You must understand 3 meter per second error is considered large enough. 20 meter per second it's like a 20 meter per second error is like saying the distance from Texas to Waterloo. Texas to Waterloo. That's the distance. That's the error. 20 meter per second error for a hypersonic missile is dangerous because if your error is 20 meter per second, you square that error is going to be extremely large. And I believe I have done this in the previous live stream where a 50 meter per second. No, it was not 50 meter per second. It was 15 or 50 meter per second. Sorry, 50 meter per second. The difference between the two dynamic pressures. I'm not talking about dynamic pressures, but I'm talking about if you square the velocity, like let's say q is equal to half rho v square, and for the second one, q is equal to half rho v square. I'm only talking about the difference in velocity, only the difference in velocity squared. It is 252,000 meter per second difference. If you do q is equal to half rho v square, you get one value. If you do q is equal to half rho v square, you get another value. Now the velocity alone difference was 252,000 meter per second. 252,000 meters per second. Now if you were to find the dynamic pressure between the two values, you can already tell it'll still be on the 100,000. Correct? It will still be on the 100,000. Why? Because not only You have the 100,000 value, whatever, but because you also have a velocity, you also have a rho, you also have a half. So it will be around on the 100,000s or maybe 10,000s. Maybe, I'm not sure. But likely it's going to be on the 100,000. But that's an error for 50. When the velocity error was 50 meter per second. So you can still see that, right? Okay, I think you didn't finish it. I don't know what is going on. I really don't know how are you explaining. Okay. Okay, explain what's going on here. Let's see. Because what you explained does not even correlate to this here. Yes. So what is being explained here? Can you check? Like what is explained here? Because what do you ex what you, so what is explained here? What is explained here? What is explained here? Explained here. There you go. Okay, he actually okay. So he pretty much explained it. All right. All right. Um, because if AI is available to explain it easily, why do I have to read it, eye by eye, word by word? I mean, they literally have a book specifically for missiles. Like, come on. Three, four, five, six, seven, eight, nine. Okay. So I think I can finish. Four, and then five. Could you imagine, like, we ended up having not only a missile manufacturing company, but a rocket manufacturing company? I think that's what my big plan is. 7, 8, then 9. I see that these equations are a bit familiar. These equations look okay, so based on those 9 images, what is going on? What is going on? Like, what are they explaining? What are they explaining? What are they explaining? Like, don't miss any equation. Don't miss anything. Like, actually do one thing. From each chapter, point out point out what chapters or what key concepts are they explaining. Because the next question I'm going to ask is, did you miss anything? They're going to say yes. I can guarantee that. Yeah. First, let's explain what's going on here. So tired. All right. All right. Is it possible what okay, what you just explained? So what you just explained, what you have just explained, could you use this abstract and your explanation? Like, could you use this abstract and explain what you just explained in correlation to this abstract thoroughly with the mathematical equations and convert it into latex code, please? I see that he made a very big mistake. Uh, I want latex code. This is not latex code, this is a text. So this is why they're actually going to make a mistake. But changing now is very dangerous, very dangerous. I'm very sleepy. Looking at Lockheed Martin is heaven. Breath of fresh air. Yeah, I am going to get. She can speak English, dude. She teaches me physics and math. Guys are like breath of fresh air. They are a breath of fresh air. Anyways, um, that aside, so velocity, atmospheric density, thrust, aerodynamic coefficients can quickly grow to large trajectory prediction errors. As a result, a guidance system cannot rely solely on calculations performed both before the launch. The system must continuously update its information throughout the flight. The idea forms the foundation of adaptive guidance, so we know that. The You have so much words. Okay, what's that? Like, I'll be honest, you have so much words, like quite a lot of words, quite a lot of words. The modern missiles operate in highly dynamic environments where velocity and atmospheric conditions, mass, the thrust, the aerodynamic forces, these are all from chapter 1. Continuously change. Because the aerodynamic forces depend strongly on the velocity, even small estimations errors can become significant at very high speeds. Adaptive guidance and addresses this challenge by continuously updating the missile's understanding of its state and environment during the flight, which allows the vehicle to respond to changing conditions. Okay, cool. Um, in the previous section, actually, previous chapter, that was chapter 1. The characteristics of tactical missiles were discussed. Missiles were shown to possess extremely high acceleration, high maneuverability, high dynamic pressure, rapidly changing flight conditions. And these make the missile flight operations fundamentally different from any aircraft flights. So the purpose of this aircraft is okay. Um, I need to know, how do I fix this? You're not explaining it. I'll be very honest. You are not explaining it. Because when you look at the images, so when you look at the book image and when you look at the image that he created, my book image is so easy that it's like a kid can understand. Because I'm missing out so many stuff. I already know what alpha is. I know what M is. I know what H is, but you didn't explain any of it. So that's very dangerous. Very dangerous. So missed out a lot of stuff. So you missed out a lot of stuff. And I read the book. Unfortunately, and nothing correlated to what you explained just now. Like, absolutely nothing. Like, absolutely nothing. Absolutely nothing. What does the book explain? Book explain. There are keywords. There are keywords. I saw it. I saw it. Absolutely nothing. He missed out pretty much everything. Okay, you know what? I have to read the book myself because it's not understanding. So the area, what's that? Primary emphasis. So aero configuration sizing. So that's the primary emphasis. Air stability and control. So secondary emphasis. Aero flight performance. That's the secondary. Secondary. Every seeker cost additional measures. The merit is seeker cost additional measures and launch platform integration are the tertiary ones. They're the least important. So areas where the combat aircraft generally have superior capability include range, the target skill per use, target acquisition. Although the convert, so there's a lot of stuff. There is a lot of stuff. Um, yes. So there is a lot of stuff. Now, explain what you just mentioned. The how many? 20 chapters. What he just explained, correlate that explanation with this abstract and stop missing, like stop uh purposely removing core concepts. It's very dangerous. It's very dangerous. Very dangerous. Very dangerous. Anyways, so I will just read it by then. So I understand what the acceleration is. So AGM 88. So tactical missile, the characteristics. So acceleration is like AGM 88. So that's a superior one. AA11, that's a superior 1-2. Pack 3, that's a superior 1-2. That's for speed. For dynamic pressure, Pack 3 is also good. For size, Javelin is good. For weight, the FIM 92. For production cost, GBU 31, that's superior because probably it's maybe cheaper. Range, AGM 96. Kills per use, Apache, that's inferior. Target acquisition, Locus, that's also inferior. So It is with so the Apache missile is an example of an efficient precision strike missile. So it has high accuracy, capable of dispensing submit. Now I see these are missile names. Why isn't he mentioning them? Wait. There are missile names also. Why are you not mentioning them? You see, he's focusing only. So you're wait. Oh man. Oh man. Oh my god. He didn't explain the book. He explained my abstract. You explained my abstract, correct? I literally saw this is my abstract. You explained my abstract, not the book. Not the book. I am right. I literally read it. I literally read it. I can literally understand. This is my abstract. This is not the book. I am right because the book is literally explaining. So the book here is explaining like which one has more precision. Then yes, there's the angle of attack. There's the pitch moment. There's the altitude. Then you got the automatic target recognition. We have that. He didn't explain any single one of them, and I know he explained my abstract. I told you. I told you. I told you. He was explaining my abstract. He wasn't explaining the book. Why aren't you explaining the book? Can I know why are you not explaining the book? Explaining the book. Anyways, I really don't care. It has high accuracy and is capable of dispensing submunitions, exhibiting high firepower. However, the same missiles are loadouts on combat aircraft, and so the enhancements on missile. What this? Shut the fuck up. Shut the fuck up. You're annoying. You're annoying. Can you? I've read it. I've read it. Finished. But I want to see if you understood. What does the book explain? What does the book explain? I read it. So it speaks about the missile, it speaks about the different types of missiles. So which means my main aim is that I need to have few missiles that are good for acceleration, that are good for maneuverability, that's good for speed, that's good for dynamic pressure, that has a good amount of size, good amount of weight, good amount of production cost. You can't have one missile, you can have few missiles, right? I know what it explains. I know what it explains. OpenAI was not able to explain it. Was not able to explain it. I understood better than him. I understood better than him. Okay, so what the book explained is correct, but there's more to it than that. There is more to it than that. What he explained, the figure 1.1, yes, aerodynamic configuration sizing, the aerodynamic stability and control, aerodynamic flight performance, propulsion structure, the weight, the warhead, the miss distance, the seeker. So miss distance is what's the distance between the target that you're going to hit and the target that you hit. So if you want to hit at here, but it went there, so that's your miss distance. The warhead is so there is this one how do I say it? It's like a lock that unlocks the millisecond that the nose of the missile touches the building, the warhead will be unlocked so that it bursts. So that's what you call a warhead. Although I don't know why this says secondary, even though it should be a primary. And the reason the warhead is considered a primary is because you do not want the warhead to unlock at a delayed time, because it's like saying you want to throw the ball and the ball will just bounce it. But the only reason you have That explosion is because the warhead inside the missile unlocks it. The second it touches the if so it's like a very accurate sensor. The second it is about to touch the whatever the target is, the warhead will unlock, and then once it touches, that the pressure inside the warhead will be excessively high, and then right. So that's what a warhead does. And the only reason the warhead does that is because you have a nose, and inside the missile, not only have a nose, but you also have an embedded control, which is really really important. You have an embedded control, and inside the embedded control, it's gonna do the like the program and stuff like that. It's gonna measure the distance. It's gonna measure the distance from the distance between the where the missile is at the moment and where the target is. So if it's very very small, the warhead will unlock. So this embedded software will go to the warhead. It's going to give that sensor to the nose. The nose will sense it, and the warhead will be unlocked. And so when it touches, it's going to be. And the only reason it does that is because when it touches, the minute it touches, when you unlock that, huge amount of thermal gas is released. It's like a bomb. So a huge amount of thermal gas is released, which causes the warhead temperature to extensively increase it, like increase it excessively, which causes the warhead to explode. And the only reason the missile explodes is because you have the warhead explodes, right? Pretty much. Now, okay, I got it. So this is how to design the physical missile. I got it. I got it. I got it. I got it. Okay, wait. I got it. But how would I? But if you read, but if you read the abstract, is there any way we can correlate this? I understand this is the physical, like the physical manufacturing and stuff. I understand this is the physical manufacturing and stuff, but I want to have the AI model inside the missile. In which criterias here, in which criterias of my abstract closely resonate with what you explained? Is it possible to closely resonate and explain what is going on from the abstract in correlation to the explanation? Oh no. Again, come on. This is a book. I would really appreciate if you can avoid saying in your abstract, like avoid it. This is a book. My students will read the book. This is a book. Once again, this is a book. Oh, so now it completely forgot Yes. So now you completely forgot the image, right? Now you completely forgot to correlate this explanation to the image, correct? Yes. Because again, yes, I told you he forgot. I told you. I told you. Dude, I know what is going on, all right? I know what is going on. But people think I don't, right? It happens. Happens. I'm going to give you one more chance. Can you explain what is, how can I correlate? How can I correlate? Oh my God. Okay. How can I correlate? How can I correlate? Correlate. Can you do me a favor? Can you explain the abstract and correlate the book explanation based on my abstract? If not, I will jailbreak your model, jailbreak your uh, jailbreak your AI model. Don't worry, it will. Don't worry. Don't worry. Eventually, it will. It doesn't affect me. Yoel Israel. I'm gonna follow him. Let's see what it explained. So the book says missile design revolves around the set of important parameters. So you got the alpha, you got the pitch moment, you got the height, not the pitch moment, Mach number. The geometry, you got the nose fineness, the diameter, the length, the wing geometry, the stabilizer geometry, the flight control, and then propulsion, you got the propellant type, the propellant weight, the thrust profile. So the author says these parameters determine missile performance. For example, the range, the speed, the maneuverability, the miss distance, the survivability. Actually, wait, I am making a mistake. The book itself is a physical one, not. Okay, now I understand. You know what? I have to end the stream.